Draw on the diagram the arrow to show the velocity of the ball at P. Label this arrow V. What is the property, the most important thing when we draw that arrow? It must be tangent to the orbit. Okay? There. The velocity V there must be tangent to the orbit.
Yeah.
Of the object. There, just like that. The question 2, the acceleration of the ball at P, label with arrow A. Okay. What is the direction of the acceleration at P?
That's at P.
Acceleration. Yes, you're going in the right direction. Exactly. Yes, going down like that. Vertically down. And what is its value?
Not the acceleration 9.8 meters per second square.
Which is G equal to 9.8 meter per second square. Because again, we only study the case that the air resistance is negligible here. The statement here, negligible air resistance. Sometimes we study, we're given the question with the air resistance like the one up here with the terminal velocity, but most of the time the given problem is with no air resistance. Okay, so we've just completed the question A. Now the question B. Let me take the screenshot. Question B. Oh, that's it. We do not have question C. Very, very simple question.
Oh, that's it?
Yeah, only 2 parts. But we have a lot more things to practice, like energy and the Newton's law for a system of 2-3 objects. The ball
determine the height above the ground.
1.3 seconds to reach the wall. The initial speed is 9.2 meters per second. Determine the height above the ground at which the ball hits the wall. Given the distance from the position where the ball leaves the hand of the person to the wall is 8 meters. Given that horizontal distance. 8 meters. Calculate the height. Let me choose a different color. I think the red color. Okay, continue drawing the orbit. It might be go down like this,
Yes.
The question asks for this height when it hits the wall.
I think we need to know how long will it take to reach the wall.
To find this height, we need to find the time,
Yes.
But what is the equation to find the height here?
The height.
Open the booklet and search for the equation. Tell me which
one.
one.
I have the booklet right here.
Yeah.
Right here. Yes. Yeah. So the height is basically height, right? We have a few to choose from. Either v squared equals u squared plus 2as.
S here is the distance that the object travels in one direction.
Yes.
In this case, which direction? Because travel both direction, horizontal and vertical.
Vertical.
Okay.
So
meaning that for this question we do not need time, but how to find the S. Actually, S here in this equation is the height that we need to find, but we don't know the final velocity.
Yes.
So to find the height, we have to find the final velocity first.
Okay.
That's one method, but it's not the method that most students will do.
I think let's just do time. I think let's just do time. Just do time.
Which one?
Let's do S equals V plus U over 2. And yeah.
Wait. You said this one, which means we still need to find the final velocity.
Oh, yeah, we did. Okay. Never mind. Wait.
Actually, we can do that. Definitely can do that. It's just not, the common way to approach.
I know that. I want the
common way is use the third one. but we will do both methods to see that which one easier to think
S equals ut
come up
plus
with
1
huh?
1 over 2 at squared.
Mm-hmm.
I like this one.
Okay. So how do we find the time? T in the third formula.
So we know that the distance between the person and the wall is 8 meters.
Mm-hmm.
We know the initial velocity.
Mm-hmm.
And we I think we know acceleration.
Mm-hmm.
So we can find time. So we can cross this whole thing out and just do this one. S equals ut.
I think you made a mistake when using this equation. The 4 equation here in the booklet is applied for the motion of an object in only one direction, not 2 directions.
I know. We can put this we can calculate the initial velocity in horizontal.
Mm-hmm.
Horizontally.
Mm-hmm.
So we have time 9.2. Let's start real quick. Here.
Mm-hmm.
Okay. And I think that is 48.
I got the point that you are calculating the horizontal velocity.
Yes.
And what is the next step? How do we find the time?
Take the 8 meters and divide that the initial velocity to get the time.
Horizontal velocity.
Horizontal velocity.
Let's call that horizontal velocity ux is equal to u multiplied with sine or cosine.
That is, I think, which way? Let's go.
This is the initial velocity.
Sine? Is it sine?
This is the angle 48 degree. The horizontal component is the initial velocity multiplied with cosine of 48.
Oh, cosine, yeah.
Cosine
48.
Mm-hmm.
Which
is 9.2 times cosine 48. Let's calculate that thing.
Okay, it is
cosine 48. That's wrong. Radian something. Degree.
6.15. 6.1. The 6.15. 6.15. So
the calculator here doesn't work. I do the calculation on another calculator. I need to convert this thing into degree. Okay, cosine 48 multiplied with 9.2. You're right, 6.156. Too many numbers. 6.156 meter per second. Now we find the time that the ball travel from the hand of the person to the wall, hitting the wall. That time is the distance, horizontal distance, 8 meter divided by this speed, 6.156. Okay, 8.6.156. Is that the correct one? 156. Yeah. Approximately 1.3. 1.30 second. Okay. Now, actually, to find the height, we're gonna change this given equation in the booklet here a little bit by adding an initial height. This equation now assume that I am using this equation for the vertical component only. S here is the vertical coordinate, the y coordinate.
Yeah.
And the u in fifth formula is actually the vertical velocity, not horizontal velocity. And the acceleration here is 9.8 there. So for this formula, I will need to add an initial height, y0 initial height, which is the height of the ball when leaving the hand, which is 1.8 meter. Okay? Because this formula in the booklet is the distance, that the displacement of the ball, assuming that the initial position is 0, meaning that without y0 here, it means that we choose the coordinate system so that the position the ball leaves the hand is the origin. This is the y direction. This is the x direction. But using that formula and with the time that we've just calculated, 1.3 seconds here, substituting the time 1.3 seconds here into this formula, ut plus 1/2 at squared, we know its displacement compared to the origin O, which is the starting point. Okay, and that displacement is not the height in the questions. Therefore, I will change the coordinate system so that the origin is on the ground. It's at the
Wait,
ground.
Can't you just add the 1.8 meters later?
Exactly. Yeah. Yeah, we can do that later. That's okay. Yes, we can do that. Okay, so let's do that. Calculate the displacement, with this is the coordinate system. Okay, so now calculate that displacement, Let's go y, or just use the letter s. We can write one word to indicate what it means, displacement from starting point.
Yes.
The starting point. That s is uy multiplied with this time plus 1/2 at squared. Substituting value into it. Uy initial vertical velocity is 9.2 multiplied with sine of 48 degree, not the cosine, The time is 1.3 seconds. Then 1/2 of 9.8 and 1.3 squared. Okay, please calculate this displacement.
Are you sure this is correct?
Wait. Yeah, sorry, I made a mistake. The expression is minus 9.8 because the initial velocity here is positive upward, upward direction. This expression is downward.
Okay.
Negative displacement.
So
downward.
let's do this again. Let me just make sure.
Yeah, that's good. That when we are not so sure about the calculation, or even when we're sure, we should do it twice. Double check,
Yes. 1.8. 1.3. So, I got 0.6.
6 and something, or just 60?
60.
60 meters.
60 meters.
Okay. It means that the position of the ball is 0.6 meter above the origin. Here, this is horizontal level, Let me draw that line, horizontal level. And here, that distance that we've just found is this one, 0.6, okay, meter. That is the displacement compared to the height of the origin when the time is 1.3 seconds when the ball hits the wall. Okay, and the last step to calculate the height, we add this value 0.6 with the initial height of the ball, which is 1.8. Okay, so the height is 1.8 initial height plus 0.6, which is 2.4 meter. Okay, let's check the answer. 2.4 there. Definitely correct. Great job, both of us.
Okay. Yes.
Are you absolutely surely understand this problem?
Yes.
Yeah, and the 3 marks. Let's check the mark. This first step, calculating the time, is 1 mark. The second step, calculating the thing here, is second, and this is the third one. Okay. Vy vertical velocity, the height, they combine the step. But these are the 3 main important step to get a full mark. Okay, so the point that I would like to recap and emphasize one more time is that the 4 formulas given in the booklet, applicable only for one-dimensional motion. And for this projectile motion of an object, the ball, in 2 dimensions, horizontal and vertical dimensions, we have to separate them, the 2 movements in 2 directions separately, to analyze them. The horizontal movement is a constant movement with constant velocity and 0 acceleration, horizontal motion. That's why we can calculate the time by taking the distance and divide it by the horizontal speed. Okay? And the vertical motion is an accelerated motion with the acceleration is g minus 9.8 meters per second square in the downward direction. Yeah, we can return and practice with other similar questions in the past paper relating to the projectile motion later. But now I think we should do a question about energy to cover like most of the topic. This is momentum. Yeah, a good question in the recent year 2024 also about momentum and energy, both things. A stationary ball is hanging from a light string. A pellet from an air rifle is traveling horizontally and becomes embedded in the ball. The velocity of the pellet and when it strikes the ball is 160 meters per second. The following data is given. The mass of the ball is 250 grams and the mass of the pellet is 2 grams. Calculate the speed of the ball and the pellet immediately after the impact. They stick together. This is a momentum problem. Can you do it?
I'm thinking so.
Write the formula for the conservation of momentum. Remember that a momentum of the system is always conserved regardless of the type of collision, elastic or inelastic. Is always conserved in all collision, collisions. So we're gonna write the formula for the conservation of momentum, which is initial momentum equal final momentum. Initial momentum is the momentum of the ball, which is 2 grams multiplied with 10 to the negative 3 to convert into kilogram. Or you don't need to do conversion. It is perfectly fine because both sides of the equation, the mass on both sides are in the same unit, gram and gram, and therefore you can skip the conversion to the kilogram. That's fine. Okay, multiply with the velocity of the ball, the pellet right before striking the ball. This is the velocity, 160 meter per second. So this product, mass and velocity, is the initial momentum. Okay. Then the final momentum is the mass of 2 objects, 2 grams and 250 grams sticking together. And so therefore we add them together. Okay. Because on the right, but on the left I did the conversions. On the right, also I have to convert it into kilogram. And the velocity of the system here, V here, is what we need to find. We can solve this equation very simply, taking the number on the left and divide the number on the right to find the velocity. Easy. Okay, so please do the calculation with the calculator.
1.26.
1.26 meter per second. Let me check it. I think it's correct. Yeah, 26, and we can round it. Normally, the school teacher possibly have recommended you to write both numbers. The one which was not rounded and the later one with the significant figure. 1.3 meters.
So 1.3.
Yeah, 2 significant figure. There.
Okay.
So that's the solution for the first question. Simple, And this kind of collision, when the 2 objects stick together, is usually like 99% is an inelastic collision. But I remember, like later, there's a question asking us to find out if the collision is elastic or not elastic. Okay, now question B. Let's take the screenshot question B first before moving to C. Question B, this one. Suggest why the combined kinetic energy of the ball and the pellet after the impact is less than the kinetic energy of the pellet. Why? Explain why.
Explain why it's less. Is it because it has more mass?
No, it's not the correct answer. What happens to both objects when they collide?
They become one object.
Yeah, and why does the pellet stick to the ball? Stick to?
Because
imagine like you're throwing a stone to the mud or something soft. Can be a mattress, huh? A stone, colliding a mud. So what happened? They got distort, deformed, bị biến dạng. Và thực ra tại vì mình không có cái tool để mình observe. Ví dụ mình có một cái thermal camera, a very sensitive thermal camera, to collect, to record the process, then we see that the temperature of the two objects will increase during the collision, which means that the kinetic energy of the pellet transfer into thermal energy when they collide. The transfer occurs because of the intermolecular forces that the molecule in the ball interact with the pellet to stop it, to slow down the pellet and deform. The ball get deformed and the pellet penetrate the ball. Cái viên đạn nó cắm vào quả bóng này, nó làm cho quả bóng bị biến dạng, deformed. Và tất nhiên sự biến dạng đó thì nó sẽ transfer kinetic energy thành thermal energy. Okay.
Yes.
Và viên đạn đó nó cũng sẽ nóng lên. Of course, it will make the glass deform and break into pieces. There. Wow. Extremely slow, meaning the number of frames per second must be very high, so that we can capture this very fast moving bullet.
Wow.
Yeah, it destroy it. Make the metal parts deform and breaks into small pieces like that, releasing energy. And if you touch that thing, the metal plate, you feel it's hot because of the thermal energy converted from the kinetic energy of the ball, of the bullet. Okay, so the answer to this question contains two main ideas. The ball does a work to slow down the bullet, the pellet. The kinetic energy of the pellet is lost or transferred into thermal energy, into heat. Therefore, the kinetic energy of system is smaller than before. Okay.
Yes.
Okay, system is less than or smaller before collision. There. And the answer is like that. The work is done by the contact forces to penetrate, to deform, and change the shape of the ball. The interaction causes deformation of the ball. That's the second expression, the equivalent to each other. And this requires the energy transfer from kinetic energy to other forms, in this case, heat and internal energy. All internal energy, they are actually similar to each other. Heat or thermal energy, or internal energy. Okay, question C. With the ball with the embedded pellet rises to maximum height vertical height h small h here. Draw and label the free body diagram of the ball at a high h. Okay, firstly, how many forces acting on the ball at this new position, rising to the new height, and what is the length of each arrow compared to each other? What is how to draw the diagram correctly?
Okay, so
firstly, the weight.
The weight, yes, and then we have the tension.
Along the string, of course. And what is the length of the tension? How do we draw it correctly? What's the length compared to the weight? Tension.
I think it has to be
the vertical component of the tension here, Ty, vertical component, must equal to the weight. That's the key. Obviously, the horizontal component, Tx, they form a rectangle, huh? Okay.
Yes.
So the point is this thing in the highlight, the vertical component equal to the weight. So that they equal to each other like that, so that the ball does not move up anymore. This is the maximum new height. Okay, max height does not move upward anymore. The force becomes zero there. Actually, the reason that an object stops moving is not because the force is zero. It can keep moving even though the force acting on it is different from zero.
I think it's of air resistance.
In this case, they ignore the resistance in the statement. I think so. Somewhere, horizontal become embedded in the ball. They didn't mention air resistance. And anyway, when S rises to the maximum height, the speed becomes zero at this extreme point, maximum height. The speed is zero, and therefore the air resistance is zero. Because in the previous problem, we've learned that the air resistance is proportional to the square of the speed. So speed zero, air resistance zero. Okay? The ball is small, usually small, and the speed is not high enough so that the air resistance is normally negligible. So this is the point. Again, the force is zero is not the reason why an object does not move any further upward. It basically just converts all the kinetic energy into gravitational potential energy. No more kinetic energy, therefore it has reached the maximum height. In other words, the gravitational force has slowed it down, reducing the velocity until zero at this maximum height. Okay?
Yes.
But when you answer a real exam paper, do not draw the component T1 and Tx, only draw the two arrow, the red arrow, T
it's just two,
and W.
Just draw two of them.
Okay, that's one more question. Let's try the next one, collision ratio. Okay, this one is interesting. It's kinda difficult, not easy. 1/2. Trying to find it. Okay. Given the mass of one object is 1 kilogram, the mass of the other is 3 kilograms, the speed, velocity of one object is 4 meters per second to the right. And the question is the ratio of kinetic energy.
Before and after. After and before. So the card, what is the kinetic?
They stick together after the collision. Stick together.
Okay. So, for example, kinetic.
The question is the ratio. So we have to use the formula for kinetic energy 1/2 mv squared. 1 half
Yeah,
mv square.
mv square.
M
mv
of
square.
the first one is 1 kilogram. Let's write that number, 1 kilogram multiplied with 4 square. So the point is that we have to find the kinetic energy of the system after the collision. Oh, sorry, the thing that I wrote here is the before the collision. It should be at the bottom, huh?
Yeah.
Before collision. 1 half, the mass is 1 kilogram, the speed is 4 square. So we have to find the kinetic energy after the collision. How? Final kinetic energy.
So we have 1/2 mv squared. We have m, but we don't know v.
Actually, we can find it by using what?
Momentum.
Yes, exactly. Similar with the pellet and the ball here. Exactly similar with this method. Stick together.
Because in a system, momentum is conserved, so
yeah, they stick together.
Okay, let's do the same thing below.
So please write your solution on your notebook, and then tell me the value of the velocity of the two objects sticking together. Okay?
Okay, wait.
Do it yourself.
Wait. Yes.
Yeah, I wrote there the conservation momentum and the final velocity of the two objects sticking together 1 meter per second. Therefore, the kinetic energy here is 1/2. The mass system is 1 plus 3, which is 4, multiplied with the speed 1 square. Over this thing, 4 square is 16, over 2 is 8. Okay, the top 4/2 is 2. 2 times 1 is 2 over 8, 1/4. Correct. This is correct answer. Good job. Okay. One more problem, which is paper 1 also here. What is the average power supplied by the student during the climb? Let me try, making it small so that I can take the whole screenshot. And the answer actually displayed here, answer B. We're gonna explain why.
Where is it? Where'd you put it?
This one. What's the average power supplied by the student during the climb? Climbing up.
Okay, supplied by the student during the climb. So she's climbing up. Average power supplied by the student. So we need to know the.
Oh wait, did we miss something? Oh, sorry, I missed the initial statement here. We need to read this description. Description up here. She was initially at rest on the floor, and then after climbing up the stair, to run up the stair, the top of the stair, she has a velocity v, which means that she has a kinetic energy on the top of the stair. Average power. What is the definition of power?
Definition of power. Basically, the power isn't power, just work done over time.
No, work divided by time.
Work divided by.
It's we can call it the rate of doing work.
Yeah, rate of doing work. Yes.
The work over time. And how do we calculate the work in this case?
So
that work is done by herself, meaning that the energy inside her body, chemical energy that she absorbs from the food, that work is used to convert into two things: potential energy and kinetic energy. Potential energy is mgh, climbing up the stair, and kinetic energy is 1/2 mv square. The work of her body, her chemical energy, the muscle, converts into the two types of energy: which is
over
potential
time.
kinetic radius.
All
Okay.
over time.
Yeah, and then over the time, do we know the time? No, we don't know, but we know that
No,
that's
just
the
T,
letter
just
T,
T.
just letter T, which means the answer is B, making the mass the common factor, just like that. Answer B.
Yes.
Okay. All of these questions are in the 2024 paper.
Okay.
One more thing. Force and maximum speed of the mass. Okay. Given force and distance, what can we calculate from the graph?
Wait, what is the maximum speed of the mass?
Mhm.
Where'd you go?
Given
Okay,
the force and distance. Question is maximum speed.
Okay. One is F minus force variation, so have force 14, distance 10. Okay. What's the maximum speed of the mass? So we have force and then distance. Okay.
The question is maximum speed, and we're given the force with a distance graph, and therefore from these two things we will usually think about the area of the graph and what is the meaning of this area.
That is force over distance.
Force and distance. Like if we are given a speed versus time graph, the area of this versus time graph means like speed multiplied with time, the distance that the object travel. Therefore, the area of this graph is force multiplied with distance. And what is it? We say the work.
Well, yep. Work.
And that work will be equal to the change in kinetic energy.
Which is equal to
Change in kinetic energy. Which means the final kinetic energy 1/2 mv final square minus the initial kinetic energy. But what is the initial? Here, the initial velocity 1/2 mv initial square. The initial is 1 meter per second. This one. The mass is 4 kilograms. So from this relationship, work equal change in kinetic energy, we can calculate the final velocity. Okay, please continue doing that. Calculate the work and then substituting the value, initial velocity 1, the mass is 4 kilograms, and then you can find the final velocity.
2 over 10. 17. What's the mass? 4 kilograms. So divide by 4, and then plus 1.
Okay, let me write that like a saving document. The work is area of triangle, which is 1/2 the base 10 and the height 14, equal to, let's make the mass common factor, which is 4, and then V final is what we need to find. V initial is 1, square it. Let me remove this thing. There. So in this equation, the final velocity is 6 meter per second. Okay, that's it. I'll export this file as a PDF file and send you right away. And I recommend you to continue practicing with the question. Just choose both type of the paper 1 and 2, or you do not need to select them. Just let it select automatically. Just need to choose the topic, which is mechanic, and then the level, the subject, and click the search button here. and then continue doing downward to continue the question.
Yes.
And click on this button, answer, to see the mark scheme. For example, a multiple choice. I'm looking for paper 2. For example, this paper 2, you have the mark scheme.